x equals to 3x plus 1. Hey guys, thank you very much for coming back to our YouTube channel. My name is Clinton P. Kui, and in today's video I'm going to introduce the first of a set of videos on pre-calculus. In this series we are going to be solving questions from pre-calculus topic by topic and explaining each topic comprehensively. So stick around as we bring you more of these videos. We are going to be teaching you functions and function notation in this video, and let's quickly jump right into it. Before defining function, we will want to define a general term called a relation. By definition, a relation is a correspondence between two sets, or we can define a relation as an order pair. So if we have an order pair, parenthesis 3, 2, and then we have another order pair 5, 7, we say this is a relation. In an order pair, the first value is always called the input value or the domain, and the second value is called the output value or the range. So in this case, 3 is the input value and 2 is the output value. We always assign the input value to x and the output value to y if y is a function of x. But do not get confused because we've not defined the term function. So let's go right ahead and tell you what a function is. By definition, a function is a relation in which each possible input value leads to exactly one output value. What does that mean? We listed 3 examples on the board to enhance this concept. So this is a set and this is a set, and the first value, so this first set is called the domain, and this second set is called the range. Remember, a function is a special kind of relation. Great. So P maps to M, Q maps to N, and R maps to N. We say that this particular relation is a function because according to the definition of a function, each possible input, each input value, meaning values from the domain, should lead to exactly one output value. So this R has a single output value which is N, and Q has a single output value which is N. Even though Q and R has the same output value, but each of them leads to one output value. That's the definition. So for the second diagram, we say P maps to X, Q maps to Y, and R maps to Z. And we say this is a function because each element from the input value has only one element from the output value. Remember that. And then I did not write this because I want us to figure out ourselves. Is this a function or is not a function? Thank you. So let's examine that. So we said for a particular relation to be a function, each input value must have only one output value. We have P. P has only one output value which is X. But Q has 2 output values. Q has both Y and Z. So because Q has 2 output values as opposed to one output value, we say that this is not a function. It's not a function. Great. So in summary, if you are given a particular set of values like this to determine whether it is a function or not, you must ensure that the x value does not repeat. So if we are listing this as an order pair, we have P maps to X, Q maps to Y, and Q also maps to Z. So if this is an order pair, then we have X value repeating, Q and Q. So because the X value repeats, we say that this particular relation is not a function. Let's now go right ahead and discuss function notation. So we have a particular notation we use to denote a function. Once you've understood the definition of a function, we say that the notation y equals f of x. This thing is read f of x. This defines a function named f. This is a function f. For this particular notation, y is called the dependent variable or the output value, and x is called the independent variable or the input value. So imagine you have a machine. Just imagine this for a second. You have a machine, and when you put in one, let's say, pack of biscuits into the machine brings out 5 different biscuits of the same type. So you put in one biscuit and the machine brings out 5. So we say that particular machine is a function right there. That machine is considered what? A function. So the one biscuit you put in is called the input value, or in this case, the domain. And the 5 biscuits that come out of the machine is called, you guess it, the output value or the range. Great. So if you put 2 biscuits, you have 10. If you put 3, you have 15, based on the program of that particular function. Let's now go right ahead and solve some example problems so as to enhance your understanding of what a function actually is and how do we evaluate functions at a particular value. So remember the example we gave about a machine. We have evaluate f of x equals 3x plus 1 at each of these values of x. Now, f of x equals 3x plus 1 is a function, and we previously said that f of x can be replaced with y. So f of x is the same as y. How do we evaluate this function at each of these values? Paying attention, and let's take you through. Now at x equals to 3, we can replace x within this equation. We can replace x with 3 and simplify the result. So the general function is f of x equals 3x plus 1. So you say this is the machine. We want to put 3 in the machine and see what the machine brings out. So just replace x with 3. You have f of 3. You read it as f of 3. What we just did here is to replace this, remove x, and put 3 there because x is now 3. And this will give us 3 multiplied by, so since this is 3x, it becomes 3 multiplied by x plus 1. Great. So f of 3 equals to 3 multiplied by 3, that's 9, plus 1. And f of 3 is just equals to 9 plus 1 is 10. This means that the value of f of x at x equals 3 is 10. In other words, for this particular function, if the input value is 3, then the output value will be 10. So what happens if the input value is 2? Let's quickly get that. So we write f of x equals to 3x plus 1, and then evaluate at x equals 2. We have f of 2. We're just going to replace x now with 2. f of 2 equals to 3 times 2 plus 1. So f of 2 equals 3 times 2, that's 6, plus 1, and f of 2 is equals to 7. So if the input value is 2 for this particular function, then the output value is 7. We are lastly going to do example C, and then we'll leave example D with you as a practice, and you'll be able to do that. Do that and leave your answer in the comment section of this video. f of x equals to 3x plus 1. What is f of negative 1? That means we want to put in an input value of negative 1 and see what comes out. So f of negative 1 is, say there is 3x, is 3 times negative 1 plus 1, and f of negative 1 is 3 times negative 1, that's negative 3 plus 1, and f of negative 1 is just negative 2. So if you put in negative 1, you have negative 2. Now you are going to do example D, and we are going to give you subsequent examples for you to try. Let's quickly check your comprehension on what we've just discussed, and let's see how far you go. Make sure practice these problems and submit your answers in the comment section of this particular video, and we promise to go through the solutions and point out who actually got the right answer to each of these. So practice these and post your answers in the comment section, and we're going to see you in part 2 of this series.